the T-shaped model. We'll talk about it. I have a point. Promise you. This is from the Valve Employee Handbook, which I recommend everyone take a look at. It's really interesting. Yeah. So the Valve software, like the company that makes the games and they have a really interesting handbook, and it shows their model of company, and it's actually really fascinating because it's very very flat. It's very, everyone has their own, like, you are not assigned to projects. You assign yourself a project. You pick up your desk and move it to a cluster doing a project. All the desks are moved. KV, good to see you back, buddy. How are you? A couple minutes. It was good. It was nice to get a chance to get my brain working again.
Yeah.
So I spent like the first couple days just like in front of YouTube, just watching. Like I watch a lot of like video essays and things like that. So basically, like, well, can you feed me things so I don't have to think about this? Put the conclusions in my brain, please. And then yeah.
The sound is
Like, yeah, that would be fun. Yeah, I think the hard part is it'd have to, like, especially with the kung fu and stuff, they'd have to actually filter it. Like it would have to be a little adaptive for your body. We have to be like a small whippy person's gonna have to have different moves than like I am. I think if I were in a like I've watched a lot of kung fu movies and people have like different specific abilities. There's one called the Five Venoms, and there's one guy who could just always take all of the punches. I'm pretty sure that would be my kung fu thing, because it's like I may not hit you, but I will be able. Yeah, yeah, yeah. Basically like that. Yeah, no, it's um like School of Life, Wisecrack. There was a bunch on videos. There's one guy who does this thing called Earthling Cinema, and he pretends to be an alien reviewing the artifacts of a lost civilization. And he has these crazy eyebrows that are like like a big giant mustache of an eyebrow. Anyway, yep. Okay. Should I start? I feel like maybe I should start. Yes, I should definitely start. All right. Let's go whiteboard. Full camera? Go whiteboard. Oh, hey guys. How's it going? Is this all the people? Quite all the people. Yes. I knew that. So, Ruby. Huh? Ruby. Before we do that, I wanna get a quick review of React Week. How was that for the people? How's Chatty? One of the things about the structure of the bootcamp that I really like is that week one is you're kind of doing everything. It's almost like learning to drive stick standard, where it's like you're kind of really controlling the transmission, and you know you're doing jQuery and you're really like you're manipulating the DOM and you're writing these routes in Express and you're really handling like, oh, and here's where I'm handling my authentication in my middleware. Hopefully you guys put that in the middleware. Here's where I'm handling my other stuff, right? And it's like whole thing. And then you get to the second half. Also, like, you know, you write your connects and you're really into that, like you're making all your requests and your database transactions. The second half is a little like learning to drive automatic, where we kind of give you now these more advanced tools for building stuff, and you kind of get to focus more on other aspects. So with React, who would like to who had a hard time building Chatty? Who would have liked to have done all that in jQuery? Oh, all of no hands for the sake of. I got a little like, I don't know, maybe it. Right? There's a point at which you build things of scale and jQuery is no longer an appropriate tool. This gets really hard to keep track of your code, and the problem isn't jQuery, it's you. It is the fact that we have limited bandwidth as humans, and there is an upper limit to that. And then after a while, we're starting to keep track of more things, and the program is getting bigger than our brains, basically, and we can't. We just, oh my gosh, you guys, right? Just can't. And so we use React. But it's good to know how to do these both ways. And this brings me to this handsome gentleman. This is a diagram from the Valve Employee Handbook. Who's heard of Valve software? Steam, Steam Fortress? Yeah, Portal, Portal 2, not Halo, no, the Half-Life. I had the first three letters right. Right, so great, and I really recommend taking a look at this because this is a really interesting book that describes their software model and their model for companies and stuff, and it's just like, wait with it. So, but this is the T-shaped employee, and this represents breadth of skills, which we're training you guys to be polyglots. We're training you to have breadth, where you know how to do things in this, you know how to do things in that, and we're training you in a client side, like with a library like jQuery and a full client side like framework like React. So you'll have the ability to do things in both. One of the demos you would have seen on demo day, TourneyWatch actually used jQuery instead of React. Whereas a lot of people were like using React, they were like, you know, I think we're better served using jQuery. And sure enough, they made a good app with it, right? So it's good to have a breadth, and then this is your depth. This is your thing that you get good at. And as one of the things I really recommend is that as you're focusing right now, like at Lighthouse Labs, we give you like the sliver of this guy, right? So I'd also recommend as you're going, looking at things where it's like, actually, I'm going to get good at this. I'm going to use this tool to its best ability. I'm going to get really good in this domain, this area of expertise. I'm going to get good at graphics. I'm going to get really good at security and crypto. I'm going to get good at optimizing databases. So I want, as we're going into this week, and as you're thinking about, like I know some of you guys are already meeting up about final projects, as you're going and thinking about your projects and thinking about your career and how you're going to build up your skill set, I want you to build this guy in where, yes, build that breadth, build that where I can do things in kind of an Express style web app, but I can also do things in an MVC like Rails coming on Monday, and we'll either love or hate. It's with Rails, I find that people either hate Rails or hate Express as a result of having C. So you have that to look forward to. Right, so Ruby. So far, you guys have been your imperative language of choice, and I say choice. Obviously, we made the choice for you. Your imperative language has been oh, that's not good. Oh, huh. All right. Go back to the. I'm gonna have to Slack. What's his face? There's a problem. Hold on a moment. Uh, uh, half on. I'm I am distracted for a few more minutes with abs improvised garbage, but eventually they're gonna catch on. So ignore that. Right. So Ruby. So up to now, you've been doing stuff in JavaScript. And so what you know about programming and what you know about JavaScript, like that's been the same, right? Because, and it's hard to kind of distinguish between like, it's like if you only had one like romantic relationship in your life and everything that you know about dating is just what you know about like Vanessa, right? You know, and they date somebody else, like, oh, apparently it's possible for someone to be nice to me. I never dated anyone named Vanessa. Don't worry, that's not happening. Vanessa, go out with me. Fine. Parents just want to be friends. Anyways, that's another story entirely. So, so yeah. So right now, it's almost as if you are building a Venn diagram where you have JavaScript, and all of your programming is also in this. I write like someone experiencing it. Right? So now what we're going to do is we're going to start to broaden a bit. And we're going to include Ruby. And then you're going to realize that what they have in common is programming. That makes sense. Now, Ruby and JavaScript do share some things in common that you will want to experience differently. Among other things, they are both they're both dynamically typed, which means that values have type, but variables aren't bound to a type, which is not the case in a lot of other languages like Java and C#. Java, C#, C, C++, Haskell, which I've been messing with quite a lot recently. Like, there's just a bunch of languages that a variable is of a type, and it couldn't be like, you know, in JavaScript, I can say var x equals 3, and then x equals string hello, and JavaScript's like, yeah, I get that. Whereas if I did that in C#, it would be like, you can't assign a string to an integer variable. So that's one thing that they have in common, that you may want to experience types elsewhere to get the sense of them. And then the other thing is they are both interpreted. And by interpreted, what I mean is that we, rather than us writing code that is compiled for a machine, there's basically a Ruby machine that runs your Ruby code, interprets it, kind of the same way the browser or Node runs JavaScript. Like, it doesn't. If you're dealing with C, who's done C or C++? Right. Good. Excellent. So one of the things about C and C++ is that usually there's a make step. You might have had a debugger. You can write interpreters, this sort of thing, but there's usually a make step. And the make step, what that does is like it actually makes a version of this code that fits your particular like operating system, your particular CPU architecture, right? So it kind of makes a version that fits this. Whereas with like the browser, like Google Chrome has already been compiled to fit all, like there's a version for every system. You download a Windows version, you downloaded this, you downloaded that, right? And then what happens is that that system, it's already set up to work on this particular OS and architecture, and then it just interprets your JavaScript. It takes it in a string, and then it's like, oh, this is this, and this is this. I guess I'll just do this, right? And then have JavaScript run. And Ruby's the same thing, where it's like I'm going to make a thing of Ruby, and then it's going to like just run that code. So that's also another difference. I recommend doing like it would be my recommendation to at least try some sort of compiled code from time to time. Java and C# have a compile step, except that it's like they compile it to it's kind of an in between where they do a bit of compilation and yet it still runs on a virtual machine. So your compiled Java code or compiled C# code will work on anything that has the .NET framework. So it's kind of a middle step between compiled and interpreted. That makes sense? That it's the difference between compiling and interpreting is a little bit between the difference between foreign language translation and. So if who's read the Odyssey, Homer's Odyssey, who's read it in English? Like for those of you who read it, it was probably in English, right? That's because somebody who knows ancient Greek took this book and made a new book in English. They took this and kind of like compiled it for your operating system, right? Whereas an interpreter would be like, I would just get into Greek text and I'd be like, oh, Andromoyenepe o Musa. It's saying, sing to me, O Muse of the man. No. That's the Odyssey, right? I'm trying to remember. Okay, that's the Iliad, yeah. Yeah, Arms of the Man, that's the Aeneid. Right, sorry. I was like, I'm speaking. But that's another story entirely. I was a classics nerd, by the way. So, yeah. So yeah, it would be like if I could go through and be like, oh, it says Andromoyenepe o Musa, sing to me of the man. And then like that would be me doing it live, but then every time I would need to read it to you live. But on the bright side, I could be handed any Greek text and I could be like, Papa, you don't have to already have a translator for it. So there's some nice things about having a translator work, some nice things about having an interpreter. Obviously, once a translator translates the work, you just in your own language. If you think of that. So when you're thinking about compiling versus interpretation, that's a thing. I'm going to see if I can just have this do a modicum of troubleshooting because here that it's not working. So okay, let me. Also, the camera is way high, so just a tiny little head. Sorry about that. I got. I irritate him a bit. All right. Okay. Yeah. Let me see. Okay. So I may just have to sacrifice the recording for the live. So this might not be. Yeah. This might not be great for the recording, and I apologize for that as you look back. There are other recordings of this lecture, so for them. Okay, so right. So let's actually start talking about Ruby and not talking about Ruby. Ruby is a classical OOP language. So this is one of the big differences between this and JavaScript. JavaScript is what we call multi-paradigmatic, which means that there's a few. Who knows what a programming paradigm is? Cool. So a programming paradigm is just basically a way of organizing your code. It's basically an opinion about how your code should be. So, a little bit on programming. So there's three main ones that you're going to run into. One is called the procedural. And JavaScript is actually mostly procedural, and procedural just basically says it's a list of instructions. All right, you start from the top and you work your way down to the bottom. Keep on doing this, all right? And, JavaScript is a lot of that, where it's like, even setting up an Express app is do this, do this, do this, set this up, make this, blah, 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 blah. And then we're like ready to. But usually with JavaScript, there's like a procedural step to set everything up. And then you sort of like wait for things to happen. So then there's also object-oriented programming. So who can tell me anything about object-oriented programming? Like literally anything. It's organized as objects. It's programming oriented to objects, which is pretty much the answer I was looking for. So yeah, so everything is an object, and most of your code into object definition. So that's object definitions like classes or prototypes, right? So it's like e.g. classes or prototypes. And you guys had the prototype talk, and you guys had the thing, right? So the object definition, whichever way it's created, is a blueprint and the house, right? Class is the blueprint, is the house. We kind of make things, and then we know things about objects based on their definition. If you had a blueprint, one of the things the analogies I like to give is, imagine that you're going to a friend's house, and you're driving there, and it's like you're starting to get in the neighborhood, and then you realize a little tell me around. You realize things, and you do not have time. And so you are thinking ahead, like, what am I going to do? I basically have to get there and find where is the washroom going to be in the house? Are they going to have one on the first floor? Where is that washroom going to be, right? Like, you're like, oh no. And you're driving there, and you're like, how long is it going to take me to park? How long does it take me to, and I'm going to get out the door. Like, you're planning second by second what happens when you get there. And you're driving like you are going to either arrive safely or die, right? Like, it's that time. So you get up to the house, and you're getting to their address, you're looking for their address, and then because you've never been to their house before, and you don't know what it's like, but then you breathe a sigh of relief as you realize that they live in Vancouver. You know why you breathe that sigh of relief? Because you've been in Vancouver, especially if you've lived here long enough and have had friends who rent either the bottom or the top of one of these things, right? Who's been in the Vancouver special before? Who knows what I'm talking about, right? So for the sake of this, so imagine you're like, oh, basically, this is a familiar house built on a familiar blueprint, and you know exactly where that washroom is, right? And so you just basically, you walk in the front, and you're like, hi, gotta go. And you walk just a little bit down, and then it's, I guess based on this particular, because the door's on this side, it's going to go in, and it's going to be right? But sometimes it's like it's on the left because the doors are on the left, and you just you go in, and then you're like, oh, thank God it was a Vancouver special because I know exactly where to go, right? I'm not disgracing myself in the foyer this time, okay? So it's a very similar thing with classes, because the thing that classes give us is that we know how things are built. We know where to look for things. We know immediately, like, hey, this is built on this kind of class. I know it's going to have a this and a this and a this. I'm making a game, and I have a checker, and I know it's going to have an X, and I know it's going to have a Y, and it's going to have a Boolean to tell me whether or not it's a king, right? And that is what I need to. So, right. Okay. So that is the nice part about um, classes, is that they're blueprints. And one of the great things about blueprints isn't just that you have a reliable way of creating instances, but each of those instances conforms to that blueprint. And now we know things about it and how it behaves. Another paradigm is functional programming. So all your logic is defined in your function. You guys remember talking about purity during the Redux lecture? So basically, no side effects, no and then you have abstractions that abstract away your async, your other stuff, and you kind of put them off to the corners of your app, and then you kind of like bring them when you have to. But yeah, this is a way of making really predictable modules. So those are our three programming paradigms. And Ruby, and so whereas JavaScript is multi-paradigmatic, which means that it's really easy to do procedural or OOP or functional or any combination thereof, right? It has the 20% of features of any of those paradigms to make the like let you do 80% of the OOP, right? So it has classes, but it doesn't have like abstract classes. So it can do OOP. It didn't even have classes like a few years ago. So the prototypes will be pretty much everything we wanted. In fact, we could do polymorphism, all that stuff. And with functional, I mean, you create functions at runtime, so you can do functional, but also you can do like functions at runtime. But you can also, but it doesn't have they'll call optimism. You can't do some stuff you can with functional programming. I know I'm now back to speaking Greek for most of you, but it is. All right. So um, so Ruby is a classical OOP. It has classes. It has a lot of reflection. And what reflection means in code is that we can tell things about something at runtime. We can be able to say like, hey, this method that's trying to like what this thing I got, what methods does it have? And can I just run one of those methods? So it has the ability to sort of inspect code at runtime. So while we're going, we can kind of be looking, sort of building and like being aware of what the code's doing. There's a term here called metaprogramming, and you have a lot of that in C++, where you kind of like, you can define in stuff that reflects how the thing will be built later. Like you can kind of code that's about the code, that reasons about the code, and Ruby there's that too, but it's usually at runtime where you like you can kind of look at an object and find out a lot of stuff about it. It's syntactically Python-like as opposed to JavaScript-like. So it's gonna look different, and you're gonna have to get. One of the nice things about it looking so different is that as a programmer, you assume you know what an if statement looks like, but this is gonna be a little bit different. You're as a JavaScript programmer, you're used to a function. If it doesn't have a return, it doesn't return. Whereas Ruby assumes the last expression is what it's returning. So it's a bit different, right? So it touts being easy to code. It's often used in intro to programming language and often used by non-programmers domains. Okay, so let's actually get to the root. I should probably need to pump this up. The people watching at least have some vague clue of what's going on. So, what? Right, Ruby. Got Harvey. So we're going to use it procedurally for a moment. Which it's not. I'll show you. It's not really procedural, but we're going to treat it like this. So, to create a method, create almost to create a method, we're going to use the keyword def. Who can guess what def is? Definition, exactly. So we're going to def say hi. Right. And what this is going to do is we're going to have one line that says puts. Puts is, there's two functions in Ruby that are like console.log. You have to know when to use the right one. Puts takes in a string and puts that string right on the console. So puts hi Eric. So I'm going to say hi to Derek. Now you'll notice that with a JavaScript function, I have to put this. It kind of treats everything like it's a method of something. So generally speaking, right now, this isn't a direct variable, so I can just say like, hey, say hi to Derek. And when I quit, it says hi, Derek. All right, so let's actually put in a variable here. Hi to someone. Name. You know those template strings in JavaScript with the little backticks, right? Well, we have those in JavaScript kind of thanks to CoffeeScript. And CoffeeScript borrowed their version of that from Ruby. So we have the ability to create similar template strings as long as it's the double quote. We'll talk about the difference there. But I can make a template string here and just. So now instead of saying hi to, I can say hi to. Hi to someone. Yeah, let's see what happens. Oh, no method, say hi to. Did you mean say hi to someone? This is another really cool thing about Ruby is that their helpers are actually like really good. So it's like, oh, you meant to say hi to someone. Okay. Say hi to someone. And there it's hi, Derek. And let's put in Clayton. Or mostly so that I back my people. And wanted to make her nervous. All right. So here's that form, right? But one of the things about Ruby is that it's actually really syntactically expressive and really like, it's a lot more loosey-goosey, and sometimes that loosey-goosey kind of like then doesn't work in a way, and it's like, haha. But I can actually leave out the parentheses. All right. So that's cool. Yes. Let's something slightly more interesting. What if I made a function? I decide, you know, I want that greeting to be a little more modular, so I'm going to make a function for the greeting itself. Because right now, this function, this method, I should say, all it does is it returns, or it performs an action, right? Yeah, we're all sort of okay with that. So it's very much like, you know, it doesn't tell you what happened. It just does the, right? It's like a teenager, and you're like, "What did you do today?" And it's like, "Yeah, but you Like you can't have done, like you existed for a day. Can you at least tell me you existed? Right? Like it's like that. Um, so I'm gonna do def greeting name. I'm trying to remember now if Ruby. And so I can say return I. What's although I might have to. Else here. Uh, right? So I can say return, but Ruby makes this. Um, Ruby has this particular opinion about how your code should be. So when we were talking about JavaScript, let's go to Python Tutor, right? And if I wrote function say hello, console.log hello, right? This is how I would do that. What if what is this going to return? What if I say const x equals say hello Brandon? What is x going to be? Undefined, right? So you might think, so one of the things you can think of is that there is this, there's this implicit return at the end. And a return with no type is an implicit undefined, right? If you want to return something from a JavaScript function, you have to explicitly say, I am returning. With Ruby, its assumption is the last expression is meant to be the return expression. So I can write this. And since we already established that Brennan's my favorite, I want somebody to be like, there you go, Brennan. I can say this: if name is Brendan, all right. So I'm going to say hi to someone. Hi, Blake. Hi, Brennan. You make bastard. Let's take a look at this statement. All right. If name equals Brendan, else end. Now, if you use an if, you have to use an end. There's also else if. Into it in a moment. Not like Elsa. All right, just let it go. So that's a joke for any like 5-year-olds who are watching this, I guess. So if name is Brendan, well, so greeting name is still returning something, but it's just saying like, hey, at the end of this, I'm returning this. So this is like a ternary expression, right? You guys know what I mean by ternary expression? One of those conditional fellers. And you can actually use a ternary expression. I don't think I need to. Right? Still able to use that particular construction, but I'm also getting that by default using. So yeah, that it's kind of, you guys remember me talking about expressions versus instructions on the Redux thing? We're talking about sometimes your code like we really care about it as an expression, as it like this function should return something, this thing something, whereas otherwise it's like that teenage did a thing. What'd you do? I don't know. Right? So it's not that I don't like teenagers. I have a bunch of nieces from being like Uncle Joel to like, all right. Okay, so this has been a bit of that. If one of the things I want you to take away from this particular thing is just a set of expectations of how Ruby is similar to Java. Like we still have the ternary expression, we still have if and else, can do. I can still put kind of the, you know, instructions have side effects. Right? There it is. Running time. Um, okay, so this is a bit of the structure um, of methods. Let's do variables. Okay. So how do I make a variable? You know, in JavaScript, if I was about to make a variable, what would I need? What keyword? There's one of three keywords that I need. What are those three keywords? Const, let, and var. What do I do in Ruby? Just the name. Just the name. So um, name. Two R's, two S's. Two S's. There. And then I say hi to someone. Person name, right? That's how I can do that. So there I've done a variable, made a variable, respective thing. So this is, yeah, this is kind of the basics of like, it's really easy to kind of create that, and then it's going to exist within its scope, which means that like if I put in if, I'm pretty sure it's not available outside. Let's double check that. Def check scope if x equals puts oh okay. So I guess it keeps also while I'm at it, check scope. Okay, so now it's local to this function method rather, but oh here I can't do anything. No undefined local variable name. Okay. Touch hashes.rb. Another quirk of the language are what we call symbols. But it's okay. You guys are eight. All right. So what's a symbol? A symbol is a unique. Is it basically? It's we call a singleton string. Symbols are. Who can tell me what a singleton is? For all you computer science students, you ever run into a singleton? All right. So a singleton basically means there's only ever one of these for the entire program. It's a really common pattern. I once had it as an interview question, like how do you create a singleton in JavaScript? And the idea is, let's say that I made string 1 waffle, right? And string 2 equals waffle, right? Same string. And I could say puts and this would be true, right? They're equal to. But if we actually look, we're going to see that there's what that means. So if I put string 1 dot e, I get out this number. And if I put dot id, notice I'll get these two numbers are different, which seems like, okay, they have different numbers. But what that's basically saying is that they are being held in two different places in memory. So the memory is making a new string for both of those. If I had said string 2 equals 1, then they'd be the same, but I didn't, did I? I just said this is waffle and this is waffle. Okay? So that means that they're equal to each other, but they're still pointing to two strings. They're being stored in two different places in memory, not common. So what symbols do, symbols, you can think of them as the sort of strings that the client will, right? Whose code does stuff with strings? Like, hey, if its role is admin, right? The end user might not see role admin; they might see some other stuff, or admin true. So what symbols let us do is they let us create things that are kind of these unique strings. So I start with a colon, or Conrad says, and I'm going to make another one, symbol 1, symbol 2, puts 1, 2, right? So there's another true down here, separate. But I want you to see puts sim1 dot id and puts id. So you'll see they actually point to the same ID, and also you'll notice their ID is really. So basically, Ruby finds these and like, hey, if I don't have it, I'm going to create a thing, but if I do, I'm going to have it. So there's only one of these. It doesn't matter if in some other file in the program I say colon waffle, it's going to be the exact same symbol it's pointing to. So it's going to kind of save memory. And the other nice part about this is that we basically treat these like strings for code. So when we're writing code, we have these, and it's really kind of a handy way of defining some strings we're going to be using in our code, something we're not. If you guys remember my thing on Redux and how like I had a type and I would have like a string there. So this is like that, but it's more for the system to care about. The end user doesn't care about these strings. They should never see them. They just this is never going to find its way in front of an actual like user. These are going to find their ways maybe into the API, but nothing other than that. So you're going to see a lot of these in your code. You're going to use a lot of them. And that brings me to hashes. These are a lot like JavaScript hashes. and you can use JavaScript language here. First name. All right. And I'm going to. So I have this. And you'll notice that in its actual form, it's kind of written like symbol, arrow, right? And this is another way I could easily write this, but the convention has become to write it in M. Yeah. So this is a hash, and we can use all the stuff. So what if I wanted to get the first name out? If this were JavaScript, well, how would I write that? Right. And it's saying undefined method first name. So when we have a thing and we dot something else, even if it's like an instance variable, like we use hashes, Ruby treats those like a method, and this doesn't have that method. You'll get used to this a lot, where Ruby, like, kind of everything is a method. Everything. So what we have to do is use the arrows. And so this would be like if we were doing this in JavaScript, right? This. No. And right now it's saying nil. That's its. Instead of null and defined, it has. So if we say first name, so this is how we're going to get stuff in, and you're going to find yourself working with it quite a lot. So get used to that. Okay. Those are symbols. Those are hashes. Let's make that greet again. Def get thing person. So now I'm going to do this based on a hash, not a. And how do I get, like, I want basically this, except without the Brendan, Ignorance Ambassador bit. So I'm just going to say hi. How do I get the first name out? Person, first name. Person, last name. Okay. And I'm going to say def, all right, no political stuff, no political stuff. So yeah. Person puts get greeter. Right? So if I say hi to hash, it is going to hi Amy. Okay, so there I've said hi to this hash, but let's say that I want to just include it as a parameter, a function argument, right? Well, I can create one of these. Person name, Cody Sampson, right? Last name Thompson, not Sampson. Right? And so if we say hi, then like, there we go. Hi, Cody Thompson. But one of the interesting things about Ruby is that I can actually out, and if I have more parameters kind of at the end that are like written as a hash, it'll interpret these different, what looks kind of like different parameters as one single hash. So if I say word person, word, and here I'm saying was up, then this first string without any kind of hashy stuff, that's going to be word, and then the rest of the hash is the person. So oh right, sorry, I've been doing of Haskell. Leave out the comma. Right. Right. So we have that separation. So it's really interesting. You're going to see a lot of functions or methods written this way, where you kind of pass in a hash. You may be wondering what they look like on the end, and this look like. So if I put in the hash without the thing, it just into a. I can then get the stuff out. All right, we are at 9:55. I think it's time for coffee. When we come back, we're going to talk classes. Where did about? Okay, yeah. Alex. My laptop is on the screen, but not in the. I was messing with it.
So make sure that you guys just keep your stuff
Yeah.
Well, not the number of dogs we have in there.
Yeah. Which really brings down your pet food budget. So. That's true. They went in. It's a quiet court.
It's just make noise for me.
It's for me.
Receiving one or them actually receiving one?
Giving one.
Which man?
Oh yeah. He's not an actor.
Possible. I meet a lot of people.
Not someone. Pretend. Probably.
I meet a lot of people and then forget the men.
Hi, I'm Don.
A long laugh. Except for the sort of curly. How's it going, Sam?
I'm girly looking. Would it be Fort Worth?
Oh, it looks like it's. Oh.
Alex.
I was wondering where all the stars are.
Hey, buddy. I have a tech difficulty,
Me,
which is that my laptop, but when I split screen, no signal.
really?
I
Yeah.
do, but my name sucks.
So right now I'm doing everything like as big a font as I can, and be like, well, a lot of people will keep happy.
Yeah.
Yeah. So
The whole situation. Just got over the streaming situation.
okay, good. I just wanted you to know.
Everybody.
Yeah. Yes. Yeah.
But if you have any
And also, it's free coffee, but if your drink name is even slightly Italian, it's going to cost some money. Cappuccinos, lattes, the like. Oh, I've been in the week 7 lecture.
Oh, okay. I know.
Yeah.
Like,
Yeah, no, I haven't done the day one. Oh, it's going all right.
how's
It's
our station?
I think so. Yeah,
Into it?
it seems like it. It's a really quiet cohort, and it has been the entire time. So that makes them a tough read. But yeah,
Not only but we
yeah,
okay.
yeah. Yes. Right. Right. Yeah.
Which we won't be able to.
Yeah, and I think it always takes a couple of cohorts to be like, it worked fine with this cohort, but this cohort was very
That's
different.
fair too. Yeah.
Yeah. But
And
right. Yeah.
so
Yeah.
like
Yeah. That's a big thing. Yes. Yes. Yeah. Yeah. No worries. No worries. Hello, everybody. I am back. I hope you're all able to caffeinate. What? I don't know. It looks like it's like 17. Yeah. So, uh, right back to the old code mines. Okay. Um, so we talked about a few kind of like low-level Ruby syntax bits, strings and symbols, and actually we didn't talk about strings as much. I showed you templates, but I will also tell you that there are 2 types of strings in Ruby. You can actually see the 2 types of strings. So here's a double quote and here's a single quote. In JavaScript, the single quote and the double quotes are like equivalent. In Ruby, they are not. So strings RB. So string 1 equals I. String 2 equals puts. So these 2 strings, let's see if they're equal. Okay, so they are equal in their definite. They came out to the same string. That's cool. So what about this one and this one? You see a little difference already? Huh, it seems they're not the same. So let's put string 1 and string 2. So what's the difference there? It's high/n. The single quotes are incapable of doing escapes, which is really confusing when you have that. It doesn't know what to do with that. Make sure. Yeah, okay, never mind. It does know what to do with that one escape. But like, yeah, it doesn't have all the escapes, whereas this is like pretty friendly with that. So one of the other things that the double quote can do is it can do a template. How about 3 divided by 1? Here's another point. 3 divided by 2 is 1. What would that be in JavaScript? 1.5, right? I heard Kyle whispering the correct answer. So, what about 3.0 divided by 2.0? Well, that's 1.5. So, Ruby has a distinction between integers and floating point numbers. Floating point numbers are basically a number with a fractional part. And they're sort of encoded in binary very differently. So, which is an interesting thing to look up on your board. But, yeah, so we can take a number and we can say that I want this 3.2f divided by 2.2f. And that says 3 to float or 3 to... and then if we said puts 3.2i or 3.0.i divided by 2.0.i, that'll be 1. So if you're doing some math, every now and then you might find that this is a problem. So you have to switch between floating, whereas in JavaScript we have the number type. In Ruby we have floats and integers for reasons. So strings and numbers, there's the thing. That 2i, by the way, I can also do 3.i divided by 2.i. And that will be 1 as well. So it'll try to convert whatever type it is to an integer, and if it can't, it'll just, if I try to say puts a dot to I, it would say, and you can play around with that and see what it does. Okay, let's get to classes. What is a class? What does it provide? Why bother? Right? Well, classes, the blueprint, right? So classes give us a few things. And the number one thing is kind of a blueprint so that we know how things are built and know what we can expect of them. It gives us kind of packaged behavior. So we know that all of these things are going to behave this way. We're able to take a bunch of different behaviors and sort of like put them into one big thing and be like, okay, that's how we have organized our behavior. And also we're able to say this has a taxonomy. Can somebody tell me what a taxonomy is? Right, it's a system of classification. So the term so for instance in zoology we have taxonomy, a scientific taxonomy. Modern biological classification has its roots in the work of Carl Linnaeus. So many consider the 5-kingdom system outdated over the 3 domains. So in the Linnaean taxonomy, he has all these classes. So basically, the big idea was there was 7 levels of getting more specific: kingdom, phylum, class, order, family, genus, and species. Right. So if you've seen anything like Canis familiaris, or yeah, that's a dog, right? Wikipedia, dog. Canis lupus familiaris or Canis familiaris, right? That is the genus and the species. So so we see the list here, right? Where I guess Canis lupus, really, Canis lupus familiaris. So they are in the Canis class, in the Canidae family, the Caniformia suborder, the Carnivora order. So every animal is, or every dog is an animal. It is a chordata, which I believe means it has it's a vertebrate. It is a mammal. It is a carnivore. So it falls within all of these particular, or it is a carnivorous mammal. So within this hierarchy, we get more and more specific until we end up at dog, right? But a dog is also all of these things going up. Every dog is an animal, just like you, right? So if you put a puffin next to a dog, they share in common that they're animals. I believe they share in common that they are chordata. Yeah, they're chordata. And then they distinguish on class. So whereas one is mammalia, one is aves, which means that one is a mammal and the other one's a bird, right? So we get a taxonomy, which is kind of a hierarchy of types. And the hierarchy of types is also it often has us saying things like every dog is an animal, but not every animal is a dog. Not every. Okay. So let's start by making a class. Class, thing, end. So between the class and the end, that's where we're going to define our thing. And who can tell me what a constructor is? I'm not entirely certain what was covered in the OOP stuff over the computer science break, but were constructors covered? Okay, so what's a constructor? Right. The thing that gets called initially, and in this class, it's going to be called initialize. And we're going to put something here, like name. So we have a name. This thing is going to have a. So this is a constructor. Def initialize name. I'm going to say that I'm also going to make an instance variable with the @ symbol. @ name equals name. So that's saying that given name the argument parameter, I'm going to make name the instance variable. Right? So A equals thing dot new. Now, one thing I need to point out with Ruby, I talked about them not having type, right? Ruby doesn't have type restrictions, so I can put anything into anything that I want. But the one restriction it does have is the arity, which means that if I have a method of any at all that defines n number of arguments, I have to pass in n number of arguments. So if I try to say thing.new, Ruby classes RB, initialize wrong number of arguments. So my new is going to be what the initialize will do. So I have to pass in one thing. Who haven't I? And now I've done it. The P is a lot more for just seeing what an object is, kind of like how console log, if you put in an object, it's actually, instead of just converting it to a string, it's going to maybe show you some things based on station. So now I have a thing with instance variable name of sen. Cool. So ostensibly, I should be able to just say puts a.name, right? Who thinks this is going to work? Who guesses from my tone that that's obviously not what's going to happen? And who knows for like actual valid Ruby reasons? All right. Undefined method name. I'm saying name the method. So even though this instance variable is there, I haven't actually exposed it. The thing. So I need to actually write a method called name. And it is going to return the value of the instance variable. And now this works. I get send. This is really common. So instance variables are private by default. If we think of an object as a house and a class as a blueprint, we might think of private variables and methods as kind of the wiring or the foundation. It's that thing that we get to kind of experience in like we don't see the foundation, we don't see the wiring, we don't see the plumbing, right? But it's there, and without it, the house would be terrible to live in, or also maybe fall down, right? We need the wiring to work, we need the plumbing to work, we need the foundation to be there. Otherwise, this house is just going to slide away, or, you know, you need to go to your neighbors if you needed to do a thing. Or even worse, the Wi-Fi won't connect, right? Oh, a nightmare. Right? So they're private by default. I can't see them from the outside. But if I make a method here, this is what's visible from the outside. This is like the drywall, you know, or any other visible part of a house. The house analogy is really breaking down for me here, but yeah. So private just means that we cannot see it, but it is part of like kind of our experience. So we can't see it from the outside, but like while we're building stuff, we have access to it. So, all right. So we have done this. Now there is actually a shorthand for this. Attribute accessor name. And what this does is it says, I'm going to create a method called name based on that is going to expose the value and allow changing the value, basically read and write abilities, to the variable, the instance variable name. So here I have this name sen, a.name equals Arthur. And then if I EA puts a.name, same thing happens, right? It's changed that. And I got all of that out of just saying attribute accessor. The read-only version would be attribute reader, and the write-only version would be attribute writer. Okay. So we've covered some things, have access to this other thing. Let's say for a moment that I actually wanted to have something assigned to the class itself. Like, let's say I was doing a math class. Mathy. And I wanted to have, like, the distance between 2 points, right? And I want to say, like, if I had the distance between mathy.dist 0, 0, and 3, 4, like, what should the distance between those two be? Those 2 points, 0, 0, and 3, 4. 5, if I'm not mistaken? Final answer? So, but this isn't a method being called on the mathy, on an instance of the mathy object, but on the class itself. So I can say def self dot distance x1, y1, x2, y2. And here I'm going to say, I'm going to make a local variable here, dy equals dx equals x2 minus x1, y equals y2 minus y1. And it's math.square root. I think, hold on, I'm going to double check. Ruby square root. Right. So this is, oh, star is the exponent. Oh, right. Well, let's do what she said. I wouldn't be shocked if the math.square root is like optimized, but let's run that. So dx2 plus dy 2 0.5. 0.5? So now, yeah, 5.0. That's what we ended up with. Which is what we were looking for, right? So by using self.dist, we're actually applying it to the, it's almost like, rather than looking at a house, we're looking at the blueprint. And like notes are written on the blueprint about something. So you might, yeah, this is a great way of kind of describing stuff that's like, this is kind of, this class is the right place to put this information, but not necessarily the right, the class is the right place to put the information, but not on an instance. Like there's no instance of the class mathy, right? That makes sense to me. Yeah, and that's math is a good example of that because it's like, hey, I just want a library of information. I just want a library of like stuff. And you may have a trig class, and you might have something. I think a good example here would be if I did a vector, a 2D vector, and I might say self.dist v1, v2, and say like, hey, v1.x minus v2.x, or other way around. It doesn't matter, I guess. v1.y, v2.y, you know, blah, 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 right? And then I might say that like def initialize xy, and I say equals x at y equals y, and I also have, you know, attribute reader x y. I think that's, yeah, that's right. So I might also have a def distance. So this one is now just, I can make a new thing and get the distance from another thing. And all I'm going to say here is return mathy dot dist self v2. So then if I put not mathy, also, yeah, not mathy, just vector2, vector2 dot new 0 0 dot dist vector2 before, like this is going to be the same thing as puts vector to dot dist. You know, if I have these two vectors, v equals vector 2 dot new. So puts v1 dot dist v2 is going to be the same as vector 2 dot dist v1 v2. So the second version is a static method, and we say static because it stays with the class, whereas this is an instance method. So even though these two are doing the same thing, and in fact the instance method just has a link to the static one, they're kind of in two different forms. So this is one way of like seeing the same functionality written in from two different perspectives. And Ruby, right? And they both end up equaling the same thing, 5.0, 5.0, but it's just one is from one perspective and the other one is from another perspective. And it might be easier to be like who would rather write this than this? Anyone? Anyone with me on that one? So there might be reasons to write this, but this is also kind of easier typing. Okay. So that covers how we create a class. That covers instance and static and accessors, and instance variables. That's cool. Root touch inheritance.rb. All right, inheritance. So what is inheritance? Somebody tell me what inheritance is? Right. So we have class animal, and let's say that it has every animal makes a sound, right? And I might say here like return generic animal sound, arg. Arg. A lot of animals make that particular sound. And then we have like def breathe in, and I say, you know, def initialize. I'm just gonna say here that maybe I have an oct. Everything breathes, right? So my O2 level right now is you're gonna start out at like 30, whatever that means. And if you breathe in, your O2 level plus equals 5, and def breathe out O2 level minus equals 5. And so we have this breathing thing, right? And every animal breathes, and we're okay with that. But the dog is a little more specific about how it works, right? And this is how we say that the dog extends animal. And we can do a couple things about this. So we have the same initialize. Fluffy equals dog dot new, right? And we can say fluffy dot is So the question mark, by the way, what's with that question mark? What does that mean? Right, it means it returns a boolean. It means it's a question. It's a convention, not like a syntactical necessity, but it just says like, hey, we can use question marks. So in Ruby, we often use question mark just to say like, huh? Right? So I like reading these as Fluffy is a animal. So Fluffy is an animal, and Fluffy is a dog. True, true. So we have a taxonomy. Fluffy is both a dog and animal. And I like to read this as kind of like dogs are a subset of animals. You know, the number of dogs in the world is going to be less than or equal to the number of animals in the world. If every animal was a dog, then they'd be equal. But generally speaking, you can count on the number of dogs to be less than the number of animals. That's what inherit. That's why. So that's why I like to think of like the dog is a more special type. Dog is a special type of animal. Another way to say this is that every dog is an animal. Not every animal is a dog. And another way of saying this is that the set of dogs is a subset of the set of animals. Those of you who like the set theory, right? If we made a Venn diagram, which I guess I still have control of the whiteboard because my screen thing didn't fix. If we did a Venn diagram, it'd be like animals, dogs, right? There's a few ways of thinking about how inheritance works. Another way of saying this is that everything that is true of an animal is true of a dog unless specified. Okay. So let's make dog different. We're going to override the, I thought it was overwrite for a long time, but it's override. So we're going to override the make sound, def make sound. And what we're going to do is we're going to say that instead of making arg, we're going to say woof, right? So if we put fluffy dot make sound, woof. So how can we find? I talked a little bit earlier about reflection that we can take. We can look at code at runtime, right? So let's also take p fluffy dot class. So Fluffy is a dog. Let's look at Fluffy's methods. Holy crap, there's a lot of them. Make sound, breathe in, breathe out, instance of. So you'll notice that it starts with the most recently defined stuff. It's the thing I define as a dog, and then breathe in, breathe out, so the stuff I define as an animal, and then we have kind of all the stuff of objects. I want to say e fluffy dot ancestor. Not ancestors. Ruby. Oh. It is. No, it should be. Oh, it's the right. So if I want to find out the class ancestors, I have to go class.ancestors. And then I can see dog, animal, object, kernel, basic object. So I get to see down the line of all the things that contributed to making this. Fluffy is a dog, and Fluffy is an animal, and Fluffy is an object, and Fluffy is a kernel, and Fluffy is a basic object. Interesting, right? So we can kind of see. I can also say, now we'll leave that one alone. But now, when you are finding yourself in, like, where you're doing some code and you don't know things about it and you want to find out more about it, this is a really easy way to sort of like, hey, I want to look up. I can kind of get more information. Okay. So this is a bit of reflection, and we can find out things about objects in terms of their classes, their ancestors, their methods. So as we're going, we can decide to try to operate certain things. Also, use the super keyword, or actually, let me do. So now I have with arg. So I can use the super method. And what is super referring to in this particular case of make sound? What is it referring to? Yeah, the parent version of make sound. So yeah, you guys use super. So it's basically the super class version of whatever context it is. Okay. So we talked about, look at my notes, see what it is that we wanted. We did classes, inheritance, strings, blocks. Blocks are the last thing, and then we're gonna call it. Okay. And we're gonna use the array version. So touch blocks.rb. Right, we're going to go to the Ruby documentation for array, and we're going to use this. Now, in JavaScript, maybe I'll get this running from TypeScript. JavaScript. So we are in JavaScript. Let's say that I had an array of numbers, and I wanted to just take this array of numbers and get the odd numbers. Const odds equals, get nums first, right? How can I get just the odd one? What do I do in JavaScript? What method lets me go through an array and only select certain ones based on a tester? Filter. All right, so I want to filter the odd ones. How do I write that? Pass an anonymous function. And what is that function taken as a parameter? The number, okay. And then what does it return? I just want the odd ones. Okay. And I'm going to console.log odds. Okay. Where's so forward, forward, and forward. Going through there every time. Also, now I have just one, right? So I have this is a what type of function? What do we call a function that either takes in a function or a function? It is a higher order function. There we go. So we have the same ability in Ruby, because this is a really common way of kind of dealing with it. So we have the common way, we have a way of doing this in Ruby, which is that we can have a block that we define. So def do twice. I'm doing this right. Ruby. Let's just do once. So I write this and I say what's doing thing, and I want to write the word yield. And I'm going to do so what I'm going to do is I'm going to define a block. And there's two ways to define this. One is that it's just kind of in parentheses. Well, now I'm hoping I did this right. They usually have a, but puts I. Box. So yeah, I have created a block here. But let's actually pass in a parameter, and it's n. Puts n. So what I've done here is I have passed, this is a function, this block, and we say yield. Now blocks, there's also lambdas, so this isn't exactly like functions and has some really weird things. There's also, there's two different syntaxes for this. So one is like this, and the other one, and it's like if I only have one thing to do, that's a good one. But I also might say do puts. Right. Right. So puts. So I say do, I pass in, this is like my parameter list, same thing as here. And then I do something with it, right? And the key word if you're writing something that takes a block is yield. I don't know how often you're going to be writing something that takes a block. I mean, it happens, so it's good to be prepared for it. But let's actually see how to do this in real life and for realsies. So what I'm going to do is I want to take a function, and I want to find all the odds, I want to double them, and I want to print them to the screen. Okay? So I am going to say, put these, nums equals 1, 2, 3, 4. I'm going to say odds equals nums dot. All right. This is where Ruby gets too cute for its own good, in that a lot of the names rhyme. So not select. It is. Well, I know there is reject. There's like select, reject, collect. Select item block. Deletes every element of cell. See also select. Yeah. So select returns a new array containing all elements for select for which the given block returns a true value. So nums.select, I'm going to say n mod 2 equals 1. Let's take a look at that. So now we have 1 and 3. Doubles equals odds dot. Now I know they do have the word map. There's also collect. And I'm going to go ahead and so collect n times 2. So what was 1 and 3 is now 2 and 6. And then what I want to do is I want to perform an action. This is like the for each, or a for loop in JavaScript. So I'm going to say doubles dot each. Now I can either write it like this. What's n? Right? This is fine too. 1, 2. Actually ignore the 1, but just the 2 and the 6, right? I can either put that there or do a block like this. What's n? The do end thing is especially good if you have like more stuff happening in there. But yeah, there is 2 and 6. So we're able to pass functions. And basically anything that you can do with a JavaScript filter, you should expect to be able to do with arrays here. So you can get length. I do want to actually call your attention to something, though. So I have select, and I have select! Exclamation mark is why I have to say it loudly. So what's the difference between those? When we had there's a few here that's going to have a question mark, right? Num.even, just also equal. You know, there's going to be like contains, or where's some here that have a question mark? In fact, empty, equals, frozens, include, right? But then there's a few that have a question or an exclamation mark. And basically an exclamation mark, that means that this is doing a more extreme version of whatever it was doing. So whereas select returns a new array containing all elements, select star, given the block passing in successive elements itself, deleting elements for which to return. So if I say odds equals num select, then if I print nums here, the nums is still unchanged. But if I say nums.select select, n.even, then I've actually mutated the nums array, kind of like how sort mutates it, or push, or pop, or shift, or unshift in JavaScript. Okay, so when you see an exclamation mark, you should look into it, but know that it's going to do a more extreme version of whatever it is you're trying to do. When you get to active record, there will be delete and save and create. Sorry, destroy, save, and create, and they will all have exclamation mark versions. And the difference will be that if you can't make that save, if there's some sort of problem, it'll just, like, maybe it'll return false, or maybe you just won't make the change. Whereas if you say save with the exclamation mark, and when you're talking to each other, please use the punctuation, because it'll make me happy. Oh, I think you select instead of select. But the difference is that it will throw an error if there's a problem, and that might be what you want. So I wouldn't say avoid the exclamation mark, but definitely like know which one you're using. Okay, so that is what blocks look like. That's what it looks like to execute blocks. So with these ones, select and collect, they're both doing. This is map. No, sorry, this is filter. This is map, and this is for each, right? But that's how you pass blocks in, which means that you can do this sort of like functionalist programming. There's also things called procs and lambda. So there's a few different versions of passing function on this code. Okay. I feel like I have shown you the main things to know about Ruby. There's a lot of like little cool syntactic sugar all over the place. Like, for instance, I can say 2 times do. I might be able to do this actually. Puts hi, right? Hi. I can do things like 5.years.ago. This might be a Rails thing. I hope this isn't. Okay, no. It depending on the system, they have like little things like this. So there's a lot of room to sort of like extend the language, and there's a lot of syntactic sugar to do very cool things. So be on the lookout for that. It makes Ruby a lot of fun. Can make Ruby a lot of fun. And there's also, I think the one last thing I'm going to show is something I'm going to save for the breakout. So, because I have a breakout. Thank you guys for your attention. I will talk to you later, and have a good time. Have some fun. Have some Ruby fun.